Good morning, everybody. Hope everybody had a nice weekend. Right, let's get into it. Camera's a bit wobbly today. What's going on here? Let's fix that a little bit. You can see my new shark. There we go. There. It arrived this morning. So yeah, so I can ask the shark and I can ask you guys, and we'll see which one comes up with the best answer. Right. What are we doing today? What are we doing? Let's switch over to this. Right. So, we're still trying to do this CLI tool and just get some of the concepts of what it is that we're trying to do sort of fleshed out a little bit before we start thinking about machine control stuff. You can see on my desk, however, that there's a bunch of stepper motors and the stepper motor driver and a little screen and so on like this. I was having a little fiddle around with some G-code on the weekend, so we're getting in this direction, but it's not there yet. Before that, we've got all the workflow stuff to sort out. So, right. Let me pull out the YouTube chat thingy-jigamy. There we go. So yeah, say hi in the chat. Hi Darkman, how's it going? Hi all. There we go. Righto, so what we're trying to do at the moment is go from an EDA tools list of parts, the name and the value, to a manufacturer and a part number. And we've got a bunch of code which does that. Yay. Let's have a quick look to remind ourselves what we can currently do. So we can take a list of placements, which is this kind of thing, right? With names and values. And we can take a loadout of what's in a machine. So you can have a bunch of parts that you might be using already in the machine. And we also have, what have we got here? What's this? Oh, yeah, our list of parts, the manufacturer and part number, right? Our list of parts. And then we have our mappings, which go between the placement values and the manufacturer part numbers and so on. And at the moment, we've only got the exact match variety of this, but at some point we're going to add the regular expression ones, but it's not critical to sort of the thinking of things to do the different types of matching. So we're going to skip that at the moment, but we'll add that later. And then we've got our assembly variant as well, which is basically just a list of ref deses and a name. And then at the end of all this mapping process, we get a mapping result sort of tree, and we're printing it as a tree at the moment. And yesterday, was it yesterday? Yeah, yesterday I think it was. I added a little bit extra code. I started talking about it on Friday about what happens if you can map one placement to two parts, and both of those two parts are already in the pick and place machine. It's a bit of an unusual situation, but it's not like it couldn't happen. So the idea was, what happens now is that you get conflicting rules. So I wasn't sure whether it was best to apply one rule and only ever apply one rule, or apply multiple rules and then deal with the fallout if you applied multiple rules. It turned out to be better to apply multiple rules. And we also cleaned up the implementation quite a bit in the old part mapping thing. Let's have a quick look at the part mapper. So now for every EDA placement, it uses criteria to find a mapping. Then it applies rules to the mappings that matched. Then we use the awesome Rust pattern matching, and we check the count of applied rules and the amount of part mappings. And with this information, we can then decide whether we need to display an error to the user because there was a problem, or we say, okay, and here's the mapping. So this is what we ended up with. Basically, if there is one applied rule, everything is fine. That's the happy case. Then you've got other scenarios which result in different things. So if there's no part mappings, for instance, then you need to say no part mappings. If there's one or more part mappings and no applied rules, then you say, at least one part mapping and no rules. You say no rules applied. And if there's two or more rules, you can say conflicting rules. And that's what we ended up with. And that seems to work. And this seems to be much nicer than how it was when I left you guys on Friday. So the apply rules thing, actually now all it does is apply rules, which I like. Because on Friday it was doing more than that. It was applying rules and then coming up with like an error and something like that. So it doesn't actually return anything now. It just applies rules to the mapping results, which is better. It does what it says. It does what it says. Having methods that do what they say, very important. All right. So the topic of today's video is overrides and I did write it down. Corrections, yeah. Corrections is probably not quite the right word. Substitutions is probably, but sometimes you make corrections in these things as well, right? So what do I mean by this? In your EDA tool, you might basically want to correct the things that are in this without modifying the source data. So you don't necessarily always want to go back to the EDA tool and update your schematic. It's in the schematic for a reason. You might want it to be in the schematic for a reason, but when you're doing pick and placing, you need to do part mapping and you need to make corrections for whatever reason you need to do. So for instance, perhaps you want to do, perhaps you run out of red LEDs and you're going to put blue LEDs on everything, but in your schematic it says red LED, right? So then you've got a part mapping which goes from red LED to a part number, but that's not what you want. You want to use the blue LED. So you've got to make a correction at the source side of things before you do the mapping. So that's what we're going to try and do today. I'll show you some real world examples of this now as well. Here we go. So part substitutions, real world examples. Here we are. This is what I was using with a PnP convert tool. So I would, you would go from like a resistor 0402 with no specification of voltage to one that has a specification of voltage, so that when you've got all the information, you can pick the right part number. And there's other ones with like regular expressions and so on. There's there's a bunch of different reasons why you have to fiddle around with this. And you don't always want to go back through all of your old schematics and update them and so on. You just need to know that whenever you come across this part in a schematic, sometimes there might be a reason why it needs to be mapped to a new part. Maybe the part's obsolete or something like this, but you don't want to go back and change your schematic. There's impacts in going back to changing your schematic. Sometimes you've got to upgrade the version of the schematic file to the new version of the DipTrace software or KiCad software accept or whatever, and there's problems doing it. Whatever reason, it doesn't matter. There's reasons. There's always reasons for everything, right? So that's just an example of that. So we're gonna see if we can add that functionality now. So I call these substitutions. So that's what we're going to call it in here too. Variant builder. So let's try and define a substitution. It's fairly easy. It's basically just you get where your EDA tool is. Here's the EDA input. You basically say if you see this and this, some form of pattern matching. Or exactly, we're going to do the exact match to start with, then replace it with something else and something else, and that's it. Easy. So yeah, let's do that then. And this might be an example actually here as well. So we can use this as our sort of like example. So where we've got a connector, this one's got quite a specific name on it here, right? And this might be more correct than like an old version of the schematic, for instance. So we'll try and use this. So what do we want to do then? And substitutions. Substitutions. Okay, so we're going to need the argument. Again, we'll start with the argument. And we'll see where things end up. Yeah. There's another form of substitution as well, which I've done previously, which is per refdes. This is more global, so we'll come to that a bit later. That's yeah, we'll come back to that. Maybe we can add it in this. I'm not entirely sure. I don't think so though, because it's more specific. Anyway, we'll carry on down this path. Substitutions. All right. So we've got our substitutions argument. We'll come back and deal with the file name in a moment. And we'll add that to the list of arguments. Here. Somewhere around there. Seems reasonable. All right. Then we're going to need to write those to a CSV. We're going to need to write something to a CSV and flush it. So we'll do that. And we're going to need to create a writer and at least one record of some type. Uh-oh. Substitution. What was that? Oh, there's a lorry making funny noises outside. Righto. So yeah, so we're going to create a... Oh, it's supposed to be substitutions. Damn it. Let me try that again. There we go. Substitutions. We're going to create a writer for it. Got a glass of water. I think I need one. My voice is a bit funky today. Okay, and then we're going to write something. It doesn't have a refdes. And this is specifically a dip trace substitution as well, which we might need to think about. Because there's a few different ways of doing this. Now, previously, I only did this for dip trace. Probably need to look at KiCad to have a look and see what it does. Probably need to create an example files, a couple of files with KiCad. I'm thinking perhaps it needs to be a little bit more flexible than it currently is. I don't know. Let's do what we did before with the if you remember, we had we had this EDA field. Let's do that. Otherwise, we're going to have problems deserializing it if we add support for multiple different EDA tools. So we'll add the dip trace key in there so that the deserializing code knows it should look for name and value. And then if it finds KiCad there, it should look for something else and something else, right? Or whatever. And obviously, you can only apply dip trace substitution records to dip trace placements. Yeah, that makes sense. So, dip trace substitution record. We'll go with that. Now, is it dip tray substitution record here? What do we do with these other ones? No, it's just a regular one. Because we moved the fact that it supports anything inside it. So it's just a substitution record. So what we're going to say is that if you see this and this, you replace it with that and that. And I'm just going to put pan on here. Because there's a few different ways you could implement this. You can have sort of like a field name and a value, and then another field name and another value. That might be better. The problem is CSV doesn't really support that because it's not like JSON or anything like that. Let's have a look at the CSV sort of serializer, deserializer thing first. Because maybe it supports variable length rows. Because if you imagine you've got like dip trace at the start, and then you've got name, and then you've got value for the name. Oh yeah, but how do you then go from the first one to the last one? Yeah, it doesn't fit well in a CSV file, that. Like let's break out Excel for a moment. Ugh. I know, I'm sorry. Okay. Like we've got Excel. So, if we had dip trace here, and then you said name, and then you said whatever. Then how do you put the next one in here? I mean, if you had name again, then obviously the second one is the result one, right? But it's a bit shit, isn't it? Excuse my French. Yeah, I don't like it. Let's just do the basic one. Let's not overthink this. Let's do the basic one. Right. So you go from a name and a value to a name and a value. Great. And this one will result in no change if we did this. So let's update this to say that if you see something, then you get this. Just wondering here what to do. Yeah, we'll do that. So we're going to say we're just going to say header 2p. Two position header. You actually get this, and then that can be used to look up the part. That's what we're going to say. Now, we have in here this value, hour, which we need to remove. If you see this header, then you get one of these. The value doesn't make any difference. because this is specific enough to find it. I suppose you could go black, actually. Like, because you get header pins in different colours, don't you? But that should really be probably on the part. Yeah, I'll keep that in there for now. So in that case, we'll go back up to this and put black in here. And then when we see this in the EDA file, it gets replaced with this, and then we use that to look up the part number. That's what we're trying to do. Okay, so we should be able to create the substitution record now, which is going to look a bit like one of these. There's lots of T's and I's in the word substitution. Substitution, yeah, something like that. Name, pattern, value, pattern. And we're just going to do exact match. Right. Righto, so now we can write one of those and we can run the test. And it should fail because it doesn't know what the argument is, right? It goes unexpected argument. Woohoo! So we've got our failing test. Good. So let's try and add this. Here we go. Right. So we're going to find our build command. This. Oh, it's getting good now. Look at all the things you can do with it. And it's going to be substitutions. Okay. And this is going to complain because it doesn't have this field used on it. Not quite sure why I put it there. Oh dear, don't do that. That wasn't good. We need to pass that to this. Yeah. And this is going to be substitution source. And then at some point, we're going to have to use this. Right. Not just yet, though. That will then have broken our help. And we can have a look at this and now see if it's what we want. Substitutions file. Substitutions file. Looks good to me. Devil shark. Okay. Right. So that looks like this. After the part mapping. There. Okay. Okay. Oh, yeah. That needs to go on the end here. Okay. So now what happened to the mapping? Yeah. So this is what we wanted. And what it said was unresolved mapping for the header because we haven't substituted it yet. Perfect. That's what we want. So let's substitute it. It should be fairly easy, this. Famous last words, right? How hard can it be? Right. So I suppose we also need to flesh this out and say blah 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 substitute. Let's go back and have a look at this for a bit though first, right? Because this mapping tree now, if you looked at it, you'd be like, but my EDA file says this, and I've got this in my output. You're like, where'd that come from? You don't know. You don't know. You need to know if something was substituted. So let's add that to the test as well, because that will help guide us with our decision making. So what we've got is this. This is the source, right? So if we said right, this is actually the source here, you see. Watch this. Here we go. So that is actually the source. But it got mapped to this. And then that is what we used. Yeah. So we say this got substituted for that by, and then some rule, right? And we'll print out the details of the pattern. So what we're interested in is the name pattern and the value pattern. Which were these. So let's just put these in here. And then delete this. There. Now we know what's happened to it. Now, indentation level. Do we want this here? And I guess it's sort of clearer that it got substituted. And if you see a bunch of ones which are at one level, and then you look at, then you see some others that are indented a bit, that might make you look at them a bit more closely. Yeah, we'll leave it like that. We can always change our mind later. Ooh, this is supposed to be that though. Yeah. So if you see a 2-pin head with power, you get this because of this. Yeah, cool. Okay. So we're going to try and make that. That's probably sufficient. That's probably sufficient. But I say it's sufficient. We need to say that we loaded some. Probably directly after the placements, I think, because you're dealing with the placements and so on first, I think. So we'll add it in here. Maybe 1 substitutions. Yes, I know. Plurals, stuff like that. fine for today. I died a little bit. Yes. Computer human overlap. Language. Okay, anyway. And then we're going to do the same thing down here because we still haven't deleted this double checking stuff yet. At some point we'll do that, but it's not going to be this commit. So, okay, let's make this happen then. So we need to say that we loaded stuff. So let's load things. So let's go, let substitutions equal substitutions load. Hold on. Load substitutions using the substitution source, and if there's an error, fail, and then print out a message. Of how many there were. There we go. Something like that. So we don't have this yet. Now the one that we decided it was most like was the one that had the dip trace in it, which was a part mapping record. So if we start with the part mapping loader, but first let's go let's add a mod like so, right? That will allow us to go back into, not there, here. No, not there. This, there we go. Now we can do the import, there we go. And then we can add the method. Right. Right. So part mappings was closer to what we want. So we're going to do the whole copy paste thing again. I know we probably need to come back and refactor some of this a little. Maybe we can use generics or something like that in here. I don't know. Right. And then we'll comment everything out and add things back. Let's start with the names of things. We don't need part mappings. We don't need parts either. Right. So we've got a part, load substitutions, but we don't need that. So we're going to get back a list of substitutions. And probably the name of this could be EDA substitutions. We'll go back and we'll fix the naming afterwards. And we need the source. Right. Vector substitution. Don't have a lifetime. Huh, so it's not like this one after all. I mean, some of it is. Okay. And let's do a bit of searchy replacey in this. Okay. And then we've got this part mapping. We've got this. Then we've got this build thing. Okay, let's have a look at it. So we want to return some substitutions. Fine. So that means we need substitutions. Fine. But we haven't got the type. We haven't got this substitution thing yet. So where are we going to create this? I feel this needs to be in our dip trace EDA thing. We've got EDA placement here. And we've got the type of it. So let's... Yeah. Okay. Let's make this EDA substitution. I think I want to get the name of this right here before we create it. Yeah, no. No. I think it's easier to get the naming right here. That's probably okay. This one's not though. Okay, I think that looks better. Right. So now we've got this concept of EDA substitution. So we've got this EDA placement. Let's create... And yes, I know this thing is called EDA placement and it's in an EDA mod. I may come back and review that. Because you could just have like a substitution mod and then put the thing in that, which might be better. Because it's extra noise here at this point, I think. On the name of the module, on the name of the actual structure, it's probably better that it has EDA whatever in the name still. We'll keep it consistent for now, though. I'll add to do here. Consider removing EDA prefix from EDA placement and modules. Blah. Okay, so we've got a little reminder. Okay, so EDA placement is like this. It's got a thing and then it's got the details, and this is going to be the same in the KiCad land. So we're just going to grab all of this. Yeah. When we do KiCad for this, it might be a bit of a faff, but it is quite sort of isolated from everything else. So I'm not too worried about it. And I'm going to search for placement and replace it with substitution. Okay, so an EDA substitution doesn't have a ref.des, but it does have the details on how you're supposed to do a substitution for that type of EDA tool that you're using. Right. Okay, yeah. There we go. So substitution details has more than this. right? You go from a name pattern and a value, and you go to a name and a value. And there's other ways of doing it as well, but we don't care about them today. But the defaults for dip trace when you export pick and place file is the name and the value. So we're using that because that's what everybody else will be using. So we've got our concept of all this, and we've got a bunch of things on here. And one of the things shouldn't be here, but I'm going to do a separate cleanup. And we'll delete it from both. Because at one point, these were added to a hash map, and now they've got hash being derived from it. No, if I don't remove it now, I'll forget. I'm going to delete them from here. And I'm going to delete them from here. It's possible that we want to put those back again in the future. Not today. Okay, so let's go back to our loader. All right, so now we've got this concept of an EDA substitution that we can import thus. Fantastic. Right. So in order to get a mutable list of EDA substitutions, we need to iterate over the results from a reader. So we need a reader. Oops. There we go. And therefore we need a path. Therefore we need a path buffer. Right. Then we can do our iteration. And we can print out the record. But we need this substitution record now. So we have to cast it into a substitution record. So the part mappings thing has this, which is in the CSV mod. Yeah, and we have this whole thing that's like this, where we have to build it. That's quite a lot to copy and paste, that is. So let's copy it all. Comment it out. And review. So let's get rid of this. Substitution. So we've got this substitution record. So that's what we're trying. That's what we want. Let's start with that. That's going to be this. Yeah. For the KiCad ones, this might be a bit of a problem. I think you might need a specific type of file depending on what EDA tool you're using. Because there's no way that I can specify this record thing here properly, I don't think. Because again, it's CSV, it's not a structured data format, it's just columns and rows. But that's what we're going to use for now. So I suppose we'll probably need a different loader for the KiCad one. And I guess that once you look at a placements file, you would know what format to expect the other files in, and therefore you could choose the right loader. I mean, that stands to reason, right? because there'd be no point loading up a dip trace placements and then trying to read a KiCad substitution mapping. It might turn out that they're both identical. I don't know. Okay, fine. So we said we need this structure with the EDA thing in it, which is what we said, and we want a name pattern and a value pattern, and then we want a name and a value, right? That's what we said in our test, wasn't it? That. Okay, so we need to be able to deserialize that using Pascal case, which is fine. And then in order to do that, we need a substitution thing. So let me just fix the part mapping. Thing. Place. Okay. And we already know that we need the different enum variants for the next thing. At some point there's going to be errors, but we don't need those until we try and create one. So we need to implement try from, because that's what we said in our loader. Well, we haven't yet. So we're going to do try from. There we are. Right, but we don't have this try from yet. So now we need to implement it. And in order to implement it, you need to specify the type and a method implementation, which needs to return either an error which is of this type or something else. So let's deal with the error. And this error's will have the same problem. So if it doesn't know about the EDA thing, then away you go. So we use that error if we don't know the EDA string. Yeah, seems all right. But if it's a dip trace one, then we're going to return a dip trace substitution which needs to be don't we already have this? Let me look at the other one. Yeah, we need this one as well. Yes, right, yes. Yes, we need one of these. Placement record. Yeah, we need one of these. Which is going to have the name pattern, the value pattern. And the name and a value in the same way that the other thing did. And it's going to be called dip trace substitution. Potentially, we could create something else called a criteria thing here. Potentially. Right now, let's just keep it simple. Because we always use these things together, and every time you see two fields that are always used together, it's normally an indication that they should be in their own separate structure. Normally. Right, so we were trying to implement our try from, which we can now do if it's the dip trace type. And that means we can fill in the name and value fields and also the other two fields from their corresponding CSV record. Value pan. Yeah, okay, whatever. Value. Yeah, maybe value is not the right thing to use here, but that wasn't my choice. Yeah, let's fix these. Okay, so now we've got our sort of loader thingy coming along. So we can do the try from bit now. That's fine. And then if it was okay, we need to build a substitution. And we need to add that to the list of things. And if it doesn't work, then we need to throw the error. Build EDA substitution. Right, so we need an implementation of this. What's this going to do? This is going to give us our EDA substitution. And it might give us an error. I don't know what the error is going to be right now. Right, let's have a look at our EDA substitution. Our EDA substitution has got the details thing on it and all this stuff, right? Have a look at the part mapping one again. This one's slightly different because it had to butts around between looking for parts in order to build a mapping. Build criteria. Yeah. It's a little bit different, isn't it? Let's have a look at this. So the substitution record contains all these with the EDA thing in it, right? Then the substitution record contains the fact that it's a dip trace substitution. We don't have this other sort of, it's only a temporary thing. This is, yeah, it's a bit different from the other stuff, isn't it? We can probably just deal with the records, to be honest. Let me go back and look at the definition of EDA substitution. Now we had this. We had this. This is what we're supposed to be creating. Too many structures, can't remember them all, what the difference is and where they're supposed to be and why they're there. So some of them aren't supposed to have anything to do with CSV stuff, and the other ones are supposed to have to do with CSV stuff. And we use the ones for CSV to create the other ones, and then we use these to do what we need to do with the placements, which also don't have anything to do with CSVs. That's what we're trying to do. Okay. Okay, so we're supposed to be creating EDA substitutions. Right. Okay, so let's see if we can do this. Match. Wait, substitution record is... If it's one of these ones, then we're supposed to go, okay, EDA substitution. With some details, and the details for the are of type dip trace. Yeah, okay. Are of type dip trace. And if it's one of these, then it needs some details. And the details need to be imported and have all their fields filled out. Fields get filled out from the records name pattern, the records value pattern. It feels like we've already done this. And the records name, the records value. And here, you know, we might do a criteria thing at some point. So that, yeah, okay. So now we've gone from CSV land to non-CSV land. Right. We've got non-exhaustive over here. To do. This. Something like that. No, we've already got it. It's fine. We've got it here. We don't need another one. So now I think we can load substitutions. So let's see. So, did it load any substitutions? Let's have a look. Loaded one substitution. Here we go. So we've got our substitution. We've got the source. We've got the substitutions. It says this name, value, name, value. Perfect. Okay. So now we can actually use the substitutions. That'll be good. Part mapper. Well, I might need another copy soon. Part mapper. No, not part mapper. Variant builder. Here we go. Now, I think this is where we need to do it. Just right about here. Just quick. Just there. Which way around's the camera now? I don't know. Maybe I could flip the camera image. I'm not sure. Then I could go like this. Maybe. I'll think about it. Let's have a look, see. So I suppose we need to EDA substituter. How about we go EDA substitute door substitute, and maybe we give it do we want to mutate it? Yes. Decisions, or do we want to return it? You know, do we want to copy every single placement in memory, or do we just want to modify the ones that were there? Do we want to build a new vector with updated placements in it? I don't know. Let's yeah, let's go like this. No. So we're going to move the existing one there, and then we're going to shadow the name, return it. But in order to get new placements, you need to pass it the EDA substitutions. Now, we don't want to move the substitutions into the substitute method, because we're going to need to refer back to them when we start printing out our tree a bit later. So at this point, we need a reference. Can it fail? Can it fail? I don't know right now. We'll find out later. Let's hope that it can't. I mean, it wouldn't be the end of the world to put a question mark here, really, would it? Let's get the API right to start with, and then assume that at some point it could fail if there was a problem. But that means we need to define an error type. No, let's just do it when we need it. Do it when you need it. Yagni. Create a tuple struct. No. Okay, so we're in EDA land. We're in EDA land. Let's do it here in the substitution file. Let's go struct whatever, nothing, and then go import this, nothing. And we go back to this, and we'll suppose it's going to need to be public. Now we can import it, and then now create an associated function. And I don't know why IntelliJ does this. Like, I say IntelliJ, Rust Rover, the IDEA tools. There's already an implementation block that's empty. Like, why doesn't it put it in it? It's really annoying. Maybe there's a setting that says reuse existing implementation if another one exists. Implementation block if one already exists. If anyone knows if there's an option to fix that, please let me know. Put it in the comments below and I'll find it. Righto. So we're going to try and substitute things. And we started with some substitutions. So it stands to reason that we're going to return the same kind of thing. Substitutions. Substitutions. Are these EDA substitutions? Oh, these aren't substitutions. Duh. These are the placements. EDA placements. Here we go. Come on. You can do it. And then this goes here. Right, good. So that's what we need. That's what we want to do. Okay, let's do it then. Now we've got an integration test. I feel like I just want to create a very small unit test for this. Mod. This thing. And then we need to add the attribute thing, config, test, whatever. And then we go, and then we create a test, whatever. Okay. So when EDA substitute with some EDA placement and some EDA substitutions. Not like that though. You get a result. Then assert that the results are the expected results. So that means we need some things. One of which is the expected results, which is going to be a vector. And it's going to have some things in it later. And then we need these. And these are both vectors. And they're going to have things in them too. Okay, so what are we going to put in them? What? Oh. Oh, so this is supposed to be a reference here, isn't it? A reference. Yeah. Okay, cool. All right. Right, so we're going to need a placement. Typing or just pressing Alt-Enter. That's how you program in 2024. You just press Alt-Enter and everything gets done for you. Name 1. Value 1. Right? So if we've got this placement and a substitution with some things in it, of type dip trace, which needs to be imported and the fields added missing to it. There we go. So we go name 1 because it's got a match. And then the value's got a match. Then we're going to just say substituted name. Seems reasonable, doesn't it? Substituted value. There we go. So if you've got one placement and one substitution, then you're supposed to get out a placement that's the same as the previous one. But instead of its name and value being this, they're going to be prefixed with these. Boom. Like that. Right? That's what we want, isn't it? Yeah. Unused variable EVA placement. Well, yes, because that's what we're just about to write. Not yet implemented. Fine. Okay, so now we can write it. Yeah, I mean, we could write it before, but now we've got a little unit test to make running it a bit quicker and easier. Plus, when we add all the other variations of all the different types of criteria and all this kind of stuff, we can do it at a unit test level. Okay, here we go then. What do we do? So we want to return something. So we've got to start with the EDA placements. And we want to iterate over everything and then collect at the end, right? And if we did that, we need to do iter mod. Not sure. That's interesting. Iter. Item. Yeah. So iter gives us references to EDA placement, but that's not actually what we want. We want the actual EDA placements themselves because we want to change them. So iter gives us this, but what does iter mod give us? Iter mod gives us a mutable reference to something which we can change. But this isn't defined as mutable. Not sure this is the right way of doing this. Do we want a new vector? One second, everybody. Right, sorry about that, everybody. Let's have a look. So we need to build a new vector. Maybe collect isn't the right thing. Maybe iter isn't the right thing. What can we do with it? I'm not sure what which API thing you're supposed to do here. Because this method now owns the EDA placements, right? Perhaps it's not collect. Is this one of those situations where there's a magic into that exists? Why is it not like that? Oh, because I need another one of these. No. Let's see what it says now. Yeah. Maybe you have to, I don't know, maybe you have to pull them out of the original vector. I don't see why you want to do that. I just want to modify each one, or modify some of them. Do I want to create a new vector? Hmm. I guess I do need to pull them out of the vector to create a new vector. That's what we said we're doing. The into didn't help us anyway. Let's see what else we do. So we know we need to do something else at some point on these things anyway. So we go iter, and then something. It's not really map. It's just like inspect, isn't it? Yeah, because remember we had inspect the other day that we found. So this is where you get the thing and you futz around with it. Maybe we don't need to collect them at all. Maybe I just return them back again here like this. We'll try it. Placement. Why is it moaning about this? Like what? What is this? How do you make it? I don't want anything here. I just want to make it do it. I can get an iterator. What are you supposed to do? Dot. What? Is this inspect gives you back an inspect thing, which then needs to be used by something, and it's normally the collect method that uses everything. But I'm a little bit weirded out. Like, what can you do with inspect? What implementations does inspect have? Are we doing the right thing? I mean, should we just do a for each on this? You know? Yes. See, you try and get funky with the API, and you just get unstuck. For EDA placement in EDA placements, whatever. Let's fiddle around with it here. We've got an EDA placement. Why value used after being moved? Yeah. You see? Oh. We get it. But do we want to do that? I mean, it's like mutable, not mutable. Do we want to return anything? You know, it's the same vector. I guess it doesn't really matter if we return the same one. Let's see what it says. We'll proceed. Because we're not adding or removing anything from the vector, but we could do. So if, yes, you know, we've got some criteria matching. Yeah, for EDA substitution in EDA substitutions. We could do this the other way around. Because it's, I don't know, you never know which there's going to be more of. It could be more placements than EDA substitutions, but you know, over time there might be more substitutions than placements in an example placement file. Who knows? There probably will be more substitutions over time, actually, because of all the different parts you can have. So we could iterate over the substitutions and then find the placements that match the substitutions. Let's do it that way around. Reasoning. Okay, fine. So we go over the list of substitutions and then we check to see if a substitution needs to be made in the list of placements. Fine. So we go if EDA substitution. No. How about we go match EDA substitution details. And if it's of type dip trace, with some dip trace details, if details dot matches perhaps the EDA placement, then we go details dot apply to the placement. perhaps? Do we want to apply mutable, or do we want to create a new one? We don't really want to create a new one. Let's just change it in place. Okay. And it's complaining. Yeah, okay. So if it doesn't match, then, you know, what do? Nothing. So it's fine. So we need this matches thing. And then it's moaning again. Why is it moaning? Oh, because this is supposed to be an iterator. For one. That needs to be a reference. Fine. So now we should be able to add this to one of these. Matches and apply. So let's create an implementation for this. It's going to return a Boolean. And then we also have another function which takes what? Self. And just changes it. Oh, no. It takes a reference to a EDA substitution, isn't it? No. Placement. Oh, no. It doesn't take mutable reference to itself. It takes a placement. I'm not sure if it takes an actual placement or... Well, yeah, no, it needs to be a mutable reference to it. Otherwise, it would consume it. So we go EDA placement dot. Wait. This can fail. Match EDA placement dot details. We can only do if it's the dip trace type, right? Okay. If it's a dip trace type, you get the details. Placement details. And then we go self dot. No. Placement details dot value is self value. And the other thing. Name. And we always have them this way round, and we need semicolons. And this needs to be a reference. But we need to clone it. There we go. That should do that. And then the matches bit should be something like well, we need to We need to pass the placement in still, don't we? Yeah. Okay, so we have to do the same matching thing on the EDA placement details. Yeah. And if it's a dip trace one, then we can do something with it. If it's not a dip trace one, we can't. In. If it is a dip trace one, we can check the pattern against the name and the value. And we go false. Right? But we need to replace it with something else. So we go if placement self dot EQ for now. We've got value first. Let's just ditch the if and use name. And I mean, at some point we'll do, you know. What's wrong with this? Doesn't need to be mutable. Name.pattern. Oh. Yeah. We need a reference to it. EQ takes a ref. Okay, maybe it works. No. Apply. Well, this needs to be a reference. No? Oh, but it needs to be a... No, it already is. This one needs to be intermarked here. But this can't be... There we go. Okay. Hey! It works. So we can substitute things. Amazing. It feels like the code that I'm writing today is, you know, I don't know, perhaps you could solve this with some existing technologies. It just feels like, why am I writing this kind of code? It feels a bit weird. It's like all database related stuff. You know, do this, do that, whatever, blah, blah, blah. Maybe we should be writing database code. And like database importers and database querying stuff and all this kind of stuff. I don't know. It feels like you could replace a big chunk of this system with a database. Maybe we'll get there. I don't know. But at least we'll know what we need to do because of our amazing integration functional test. So we can name this better. So we can say substitute. One placement. That's what we did, wasn't it? We took a placement and we substituted it. Seems reasonable. Oh, what happened there? Don't do that. Yeah, it's fine. So does that mean everything's going to work now? No. No, it doesn't. We're missing, I mean, we're doing substitutions. Let's run the main integration test now. And we're going to look at what it prints out. Because it should have done some substituting, but it's not going to print out the bit that we wanted in our test, right? As we said in our test, that we want, you know, this bit. But what we should find is this here in this bit, we do. We substitute stuff. Amazing. But we're not displaying it correctly to the user. So now let's poke the tree and fix that too. So variant builder. This is where we build a tree. And well, yeah. It was okay. Add mapping nodes. So I think okay, so in some cases there's no substitution, so you don't get a node on the tree. In other cases there is. So what we need is like next node to be passed into the place, you know, parent node to be passed into the bit that you need to add more things to. So all this mapping nodes and error nodes get added to this node, right? So if we said for this bit, let next node or let parent equals whatever, right? And then wherever we've got this, we put. Oh, no. What happened there? I copied the wrong thing, didn't I? Why didn't you guys tell me? Right. That should all still work. Yes. Yes, good. So now we can change our parent to either be the substitution node or leave it as it is. So I guess we can say, how do we know it was substituted? We don't. That's the problem. Damn it. We don't know if it's substituted. What are we going to do? What are we going to do? That's interesting then. Okay. So before we did this, building a mapping tree, you know, we did some substitutions. So I don't know about this. Do we do this? Do we really return it? I mean, what's the point? What's the point? We're passing a mutable one in. Let's not do this. Let's say EDA substitution result is this. Okay, so we need to know what came back from this. So let's say it's going to be a vector. Well, yeah, a vector. EDA substitution result. I mean, is it? I mean, it sort of is a result, but it's not a result. Do you know what I mean? Do you know what I mean? Yeah. So we're gonna do that, which means we need these things. Which means we need one of these, and it's going to contain some stuff. I don't know what it's contained yet. I think it's going to have some lifetimes and a thing and a thing. It's going to have a reference to the placement that it modified. Right? Placement. Right? And then it's going to have something else. Like why? But I don't know what. I don't know what's going to be in there yet. We'll find out. I guess it's like the substitution, perhaps? It probably is the substitution. Yeah. Yeah. So if it matched it, fine. Then we can create a vector of these things to return in a moment. So we can go let. Probably should have started this in the test, really, shouldn't we? Let result is this. I don't need that. You just go vec. Okay. If it applied it, then create a new one of those things that we just made. Right. Yeah. Create a new one of these things. And add it to the results. This needs to be mutable in order to allow us to add things to it. And this needs its fields. And this is going to be EDA placement. And this is going to be the EDA substitution. Right. So now we can reference them somewhere. Now, we've got this is expected placements. So we've got this result, but this isn't quite that now. EDA placements is the expected placements. Right. We don't have this expected results yet. So now we're going to have to futz around and create references and so on. Oh, this is going to be fun. And let oopsie daisy is going to be a vector of stuff. Inside that vector, we're going to need those EDA substitution result things. We're going to need one of these. One second, there's something funny going. Hold on. Okay, I'm back. Sorry. People are arriving. People are going to be people whenever people are going to be people. So we need to create a new one of these. In order to create one of these, we need some references, but we don't have any reference. So we need placement 1 and substitution 1 probably, and then we can reference them. Great. So we need to extract this. And call it substitution 1, right? And then I suppose we can join those. And then this one we can extract as well. This, all of this, there we go. New factor variable placement 1. And then join those up. Why? Why not? If I just typed it in wrong, substitution, yeah, substitution. There we go. Okay, now maybe it worked. Well, no, because reasons. So these EDA substitution result things need to implement partial EQ, like it says. Derive, debug, partial EQ. Saying it doesn't need to be mutable. But then it says it does. I don't fully understand that error message. Maybe there's something else. Yeah. Okay. So that's wrong and that's wrong. Because this is the temporary one that it just created. What are we going to do here? I don't want to clone the placement. Nor do I want to clone the substitution. What can we do here? Let's try and fix this first. It says EDA placements. EDA placements, it's a mud. So it creates a reference because of this. But that reference is then put into a result object. Yeah, I think perhaps this needs to be a mutable vector here and not like this. Because then this method won't own this. Yeah. Right. And now we're going to have lifetimes of placement. And these lifetimes for these placements are going to be the same as what we see in the result. And then we've also got the substitutions that we need as well. And that needs to be in here. And this vector has the lifetime of the substitutions. Then it should be okay with returning stuff. Except this needs to be a mutable reference to the EDA placements. But it says it can't borrow it more than once. Well, that's because what do we do here then? Do you go? Is this one of those cases where you need to do like ref or something? You need to take it out of it and fiddle around with it, and let's take it back. Should we have a vector of boxes? We haven't had to do that anywhere else. Oh, right. Yeah. Previous iteration of the loop. Yeah. What do we do here? What do we do? Is this one of those? One of these weird ones where you do this? No. Oh, we get Rust borrow check a lifetime fun now. Uh, hmm. Yeah. What are we going to do? maybe it shouldn't be mutable. Maybe this is what the problem is. Maybe we should be creating a new vector at the end of it. Let's think about that. Let's say let's call it just new placement. I don't know. How's that going to help though? This is where I get unstuck with Rust sometimes when things like this happens. This. I've dealt with this before, but I never remember. When it comes up, I never remember how I dealt with it, and what I did, and what the solution is to deal with it. Because I'm creating a new mutable reference to it when I do this, right? I don't know. I don't see how you fix this. Okay, let's think about the other things first. Right. So how are we even supposed to write this? Because I've got my placement here, and I've put it in here. And we've got placements, and we fiddle around with them all. And then eventually you fiddle around with them, right? Oh, I remember what we did with this. This isn't this, is it? No. This is the wrong thing. This is a reference that you get from the placements in the vector. That's what we did before, wasn't it? It's this one like that. Why is this called load? No. How did that happen? I don't know where that came from. And then this is going to be a reference to the first one that's in there. Yes. No. What happened there? Why is it complaining? Oh, because the placements isn't mutable. Okay. So that's dealt with that, right? I think we should be not passing a reference here. What? But you need to get it back afterwards. Let's say that you get a tuple struct back. Let's see if this works. You get a new vector back. Why not? We're not returning that yet. Right. Right. I think it feels like these needs to be in a box at this point. It feels like we need a vector of box placement so I can modify the thing that's in the box rather than use a mutable reference to it. I don't know. I'm not sure yet. Yeah, I don't know. 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 I don't know what the pattern is. So we can't do this. We can't do that. We can't do this. We can't move it out of placements because it's borrowed. EDA placements. I'm not trying to move it out of EDA placements. Yeah, and then you see you've got this expected result. We can, but this is weird. You know, you could move this over here and then you've got that. Yeah, that's weird, isn't it? Right. So what do we do now? So we've got this cannot return referencing whatever because it's borrowed on line 58. Uh, hmm. I'm really stuck with this. Like I'm still in like, you know, COO Java land, you see, and this is the kind of code that I'd write. But when you're doing in Rust, you can't do this kind of stuff. You have to think about it differently. It's like, should I be returning indexes of stuff that I'm iterating over so that I can then not borrow it mutably and futz around with it, but I still want the reference to it so that I can still refer to it later. What are you supposed to do here? What are you supposed to do? Returns a value referencing data owned by the current function. EDA placements is borrowed here. And then the other message is cannot move out of EDA placements because it is borrowed. So if we said let my new placement or just updated placements is going to be a vector. And if instead of that we did this, let's see what that gives us. Now we've not put anything in it. Right. But it's this bit here is the problem. So we've got a mutable reference to this. Right, but we don't want that. What we want is updated placements dot. No, I don't know. What do we want? Do we want? Why isn't this easy? This feels like it should be easier than it is. It feels like it should be a lot easier than this. Am I missing something here? What am I missing? I can't see any solution around this that requires that allows me to keep the reference, because this reference is created here, right? And we're trying to return a reference that's created within this method, and Rust doesn't let you do that. But we said we want a reference to we want a reference to the thing that was changed so that we can refer to it. But what I need is a reference from this. Let's go. Let's try this. This is going to be weird. Right. So I don't really like this thing. But let's just see what happens if instead of trying to use this reference directly, we create a new, we use a reference that's owned by this vector here. So if we go EDA placements, because this is what we did in the test, right? We go EDA placements dot index like this. And this thing lives as long as this thing does, right? I don't think we need this updated placements thing. I'm going to undo this. This might come back to haunt me in a moment. But I don't want it. I don't want it. I didn't like it when I wrote it, and I don't like it. We'll see what happens. EDA placements, whatever. Cannot borrow it as mutable. Because also borrowed as immutable. Probably because of this. Yes. Immutable borrower goes here. Let's not do the iter mut here. Let's do an iter, right? But now we can't deal with it. We can't do anything here. We can't apply the change here. But this one was mutable, right? So if we try that, this isn't going to work. Oh, EDA placements, yeah. This isn't going to work because it's not mutable. And then you get the same problem. How do I modify the things that are in here? Just kind of try the other API. I think it's the same problem, really, because getMut needs mutual reference to self, maybe. Deal with that later. And then you get the same problem because it's already borrowed. And this might be where you have to use the Rust APIs for the reason that they exist instead of this stuff. Oh dear. I don't see how we can do this without changing this to a box here. Instead of having a reference to it, have an actual thing. What is this? Oh yeah. Uh, Maybe something like that. I thought you go star to do it. Hold on. Oh, is it a double star because you've got a double dereference it because it's in the box? Right. Yeah. Move out of shared reference. Oh yeah. That's one of these weird ones where you... What? That's fine. Expected placements is going to be box new of one of these. Yeah, this just feels so weird and wrong right now. Cannot move shared reference. Just give me the thing that's in the box. Like, am I doing this wrong? Do I want a reference to it? Do I not want to return it? You know. No. I just keep going around in circles. So I've got a box. And I thought you're supposed to use star to get to the thing. But then we need to create a mutable reference to the thing. And you can't create a mutable reference because it's behind this thing. And then we're back to needing it's a mutt on here now. We can't borrow this as mutable because it's borrowed as immutable. Borrow checker. When it bites hard. I just want to change the name and a value and return a reference to the item in the vector that I changed so that I can refer back to it later. Why is this so difficult? What am I missing here? What am I missing? It's owned by the same thing. It's just what am I missing? We've got 1,000 borrow checker things. Look, 1, 2, 3, 4, 5 borrow checker problems. Returning this value requires EDA placements is borrow for placement. EDA placement is borrowed for placements. But it's not. Is we're just creating a new reference to it, which has a completely different lifetime because this is creating references. Is my thought about lifetimes wrong? Should this, in fact, have a static lifetime? You can't name it. I don't want to clone it. What am I supposed to do here? What am I supposed to do? I've got a placement. I stick it in a box and stick it in a list. Fine. If it's a box thing, anything can come along and get the box and then replace it with something else. A new one. change it. Okay, look. Where's it? Immutable borrow occurs on line 65. Here. Okay. Let's just not put anything in here for a moment. Is this one of these weird situations where you're supposed to do this ref mut thing here? Is this what I'm missing? Should I be passing the vector to it, or should I be? You see, I don't know. It feels like I should have this here still. But then I don't want the vector to be mutable. I just want the things. I want the thing. I want these. Is this where you're supposed to be using the different type, or like into iterator or something like that? Also borrowed as just not declared as mutable. EDA placements. Let's just mutt this. Let's just kill the assert. I don't care. Cannot borrow EDA placements because also borrowed as immutable. Oh. Right. But okay, so that bit compiles like that. Let's try now dealing with this. Then you can't borrow this. Lifetime may not live long. Placement must outlive static. Okay. Should it actually be this one now? Because I've changed this over here. And should this also be a ref like this? I've got a mutable reference to a mutable reference to a boxed EDA placement. It just seems madness. Cannot borrow is mutable more than once. Cannot return referencing. Yes. I don't want Should that be like this? Is this one of these double start? No. This EDA placement is a mutable reference to a mutable reference. I don't know why. This value requires a placement or static. Placement. Why? If you take that off, yeah. So this needs to be marked, right? This needs to be marked. It doesn't. Really? Seems pretty weird. Am I creating a new reference here? Is it going to be... What's the difference between this? Just putting random ampersands and stars on things in the vain hopes that I might get an error message that actually makes some sense to me. It's not really a way of programming. I've dealt with this stuff before, but it's been ages and I've forgotten. This is the main problem that we've got. Like, we comment this out, it compiles, but it's obviously not going to be any good. Right? I don't really want this the box thing here anyway. But let me just ditch the boxes for a moment because I'm not sure if that actually really helps anything, because I think I should just be able to change the things in this vector. I can change the things in the vector regardless of whether they're in a box or not. It proves that. But the problem is creating references to the things that I'm changing so that I can refer back to them later. I could do something stupid. I mean, I think it's stupid, but perhaps it's not stupid. Instead of returning the references to it, which is how my brain is telling me to do it, because I don't want to have to dereference it again, instead of returning references to it, return the indexes of the things that are in the vectors. I don't like this. Because if someone does something else to those vectors, then the indexes that I've just returned are then going to be incorrect. Do we have to split this up into two stages where first you iterate things and change things and futz around with things and gather numbers and so on, and then create references from these things afterwards? But this seems just mad. What I want to do. This is the fundamental problem here. What am I supposed to do here? Right. Well, I don't know. I'm getting hungry and it's annoying me, so I need a food break. So I'm going to leave it there. I'm going to get some food, look this up, and then come back to it. Because otherwise, I'll just be banging my head against the screen. Right. So just remember, folks, it's only software. How hard can it be? See you on the next one. Bye.